We are now starting our statistics unit that we'll be working on up through Christmas and a little past before your final. In lesson 5-7, we're going to be talking about scatter plots and trend lines. All of these definitions in your notes, you will be filling in from the video. So as you watch, like the definition of correlation, it's a measure of strength of a relationship between two quantities. I might write that right above positive correlation, so I have what a definition of correlation is, or at the bottom of the page. Remember, to correlate, it's a verb, it's a relationship. And if we think about this, the more students study, the higher the students' grades tend to be. So there is a correlation between the time spent studying and their grades. As you look at these definitions on this page, pause it or go to your textbook and copy these down. The key thing that we are looking for is that you can determine whether two sets of numerical data are related. You're going to graph them as ordered pairs, and if the two sets of data are related, we're going to be able to use a line to estimate or predict their values. Here's your definition of scatter plot. Again, pause it and write it down. Read it through a few times. Does it make sense? It's a way of displaying our ordered pairs. And it talks about where they're always in the first quadrant. It says if you have a scatter plot, you find trends of data. Scatter plots below are the three types of relationships we're going to see. So if you look at this, you're going to see positive correlation. I would write this part in your notes and draw the picture. I would write this part for negative correlation. As the y tends to decrease as x increases. Here the x and y are not related, and draw these pictures as you are looking at them. You're not going to see all of these notes in my flip chart in your notes. But what you now want to look at is what is your objective in 5-7. It is to write an equation for a trend line and use it to answer questions. You're going to be making scatter plots to describe the correlation. Here's just some different examples of some scatter plots you might see if you are looking at some different things. So here you might be looking at pages on a word, and if you look at that, we're looking at the duration of the average visit in seconds. So if we talk about some different ways of correlating. It says you can represent, so if you're filling in your notes, you can represent two sets of data, graphing them on an ordered pair. This will help us determine if there is a relationship. You're not going to see this page in your notes. And you can use that line that represents the data to predict other values. So in this lesson, we'll be making scatter plots, finding a line that represents it, and using that to make some predictions. As you look in your notes, scatter plot again, here's your definition. It relates two or more quantities as an ordered pair, usually in the first quadrant. Scatter plots are used to find our relationships in our data. So if there is something, any kind of relationship, that is what we are taking a look at. There is a lot of vocabulary, again, correlation, and your three different types of correlation you should have in your notes with the picture. And now on trend line. So this is on your first page of the notes of 5-7. A line that is created on a scatter plot that resembles the data. Note only positive and negative correlation. If there's no correlation, you cannot have a trend line. So how do you do it? You're going to determine 2 points from your data that create a good trend line. The next thing you're going to do, you are going to write an equation. So if we're thinking about an equation of our line using the 2 points, next thing, so you always have to identify what are your 2 points that you're going to use, and they must be on your trend line. The next thing you're going to do is you're going to find the what of the line? The slope of the line by using the slope formula. So that's where we take our y minus y from last chapter over x minus x to get our slope. We are going to use, and usually the easiest thing, since we have a point and a slope, is to use the point-slope form of an equation first. So remembering, what does that look like? Y minus y1 equals, as we are looking at that, m times x minus your x1 that you decide to use. So just kind of as you are looking at those. Then the last thing we always want to do is change our equation into slope-intercept form at the end. So we always want to get it at the end to get it in slope-intercept form. We're running out of a little room here. So slope-intercept form. Now, what we are going to do is we are going to collect some data, and the data that we're going to use in class is using from our the information that you found out using the calories and fat in some different food items, and we will talk about that in class and how to use that. What we're always going to do is, as we do this, is we are always going to, when we start writing our equation, is you will need a ruler for this or a straight edge, something to make sure, so that when, after you've plotted your points on graph paper, those of you that don't like using graph paper, you need to make sure you have this. So as we take a look, you want to first find your x1 and y1. You're going to find that point. Then your x2 and y2. And again, these you'll see a little better as we go through the example. How do you find the slope? Remember, equation for a slope, y minus y over x minus x. Usually this slope will be written as a decimal when you get your answer. If you want to leave it as a, because when we go to graph these, you're going to be looking at graphing the line and then just coming up with the equation from that. So a lot of times this answer will be a decimal when you look at that, or if you want, instead of leaving it as a mixed number or an improper fraction. Then we're going to write our equation in point slope form. You should know what this looks like, and this is kind of going to be good review for your final because you have to write all these different forms and then change it to slope intercept form, where you are now telling us your m, x plus your y-intercept that you found using this equation. So some of the words that are going to come up for you is what is interpolation, estimating values between. So if you think about that prefix inter, you can do a little internet search and look at what is the prefix. It's a prefix for, what is that talking about? The key thing I want you to keep in mind is it's always going to be between our known values. Whereas when we do an extrapolation, it's going to be outside. So again, take a look. If you want to go to look at online and take a look. What does extra mean? It's a prefix for doing what? So now as we look at your example, on that example, you're going to see example 1, making a scatter plot. Now I know some of this, you have all the information in front of you, so sometimes you kind of get in the habit of, oh, I don't really need to do too much with that. And so as you look at that, you're going to be looking and deciding, oh, how should I make a scatter plot? So this is an example for you to take a look at. The temperature on the table is at different altitudes. This is our x, this is our y. Notice they have altitude down here, so whenever you make a scatter plot, you need a label. Plain altitudes, outside temperature, you need a label down here and a label on your y-axis for temperature. You need to set the scale. You need to set a scale here. And then you're going to plot the points. So you always want to look at your data first. Always looking at treating it as an ordered pair. So when we look at the plot 1,500 meters, 55, this is our ordered pair, 1,500, 55. So the first thing we do is we make a scatter plot. And we would say that the temperature outside the plane seems to be decreasing as our altitude increases. So this would be a negative correlation. So you are going to be asked to make some different scatter plots from some information as you take a look at this next example. So the first thing we're looking at is dollars spent and the gallons of gas bought. So we are wanting to have a title. I would probably write in gasoline purchase on the top. As you do that, you also have dollars spent. I already gave you that one down here. So to the side, we should have fill in your label. Our Y is going to be the gallons bought. And again, you want to make sure you fill that in. We want to think about these as ordered pairs. So as you are doing that, you're going to go to your point. Dollars spent was $10 spent, and you bought 2.5 gallons of gas. So I would like you right now to plot these points. Pause the video, and you're going to see that I've also plotted them. So just pause the video, and you will see them plotted in just a minute. Now, once you have plotted all your points, just as I did, and all I did was from this table, looking at it as ordered pair, we want to think, as the number of gallons bought tends, the number of gallons bought tends to, if we are looking at this one, it tends to increase. The number of dollars spent also seems to increase. So we would say this has a positive correlation. So as our gallons went up, so did our price. So make sure you put this label over here also as you are looking at your table. Now, what I want you to think about is, if we are looking at the bottom of that page that got it, I want you to consider the population of the city with the number of letters in the city. Do you think this is a positive correlation, a negative correlation, or no correlation? So, question 11. As an example, think of our city, Fargo, that you live in. How many letters are in the name of the city and the approximate number of people that live here? So what I want you to do is do a little Google search or take a look at the population of Fargo. We know Fargo has 5 letters, and we now want to look at the population. So in Fargo, you're going to put down for number 11, right at the bottom of that, right below example problem 1 there. Population of Fargo, number 11, you're going to put 5 letters, Fargo, and then I want you to put the population. So you're going to have a population of Fargo. Next, I want you to think about the city of Castleton. Much smaller town, but if we look at the spelling of the word in Castleton, we are actually going to have 8 letters. And I want you to look up the population of Castleton. So I should say on your notes when you come in, the population of these two. Do a quick Google search and take a look at those. It says, is the size of the city dependent on the number of letters in the name? So as our city name, the number of letters, is our population dependent on that? Is there a positive correlation, negative correlation, or no correlation? So what you are asked to do is tell me that. I want you to answer that question. And do you think there is a correlation? Be ready to explain that. Now, what is a trend line? A trend line is a line on a scatter plot that you draw near the points to show the correlation. There should be the same number of points above and below that line. So when you are looking at this, make sure you have this definition written back on those definition pages. Again, you're going to see over here where I explained the trend line. And I talk about interpolation and extrapolation. Remember, that trend line, when you look at your line, half the points are above and below. It doesn't even have to go through any data points. Sometimes it will, but it might just be near them. So be really careful when you draw your lines. As you look at the top of the next page with problem 2, it says, well, how do we write an equation for a trend line? We'll be making the scatter plots tomorrow in class, and then we'll be trying to do our trend lines. So this one says your age and weight, the age in months for our panda, and the weight y. Notice they've had a label at the top. They put the label of each axis. They put their scale going up by 2s. Here it looks like they're going up by 6 pounds for our weight. And after 12 months, that panda is right about 55 pounds. So you had to kind of decide on a scale that you were going to use. They plotted the points, and then you want to take your ruler and draw a line. This is where we were talking about what do we do first. You have to pick the 2 points. So you can see that they picked actually 4 and 17.1, which was a data point. They also picked 8 and 37.9. Now, one thing that I would often do is I would actually pick points that I think, like in this point, to me this looks like 9, and directly at, if I'm looking at halfway up here, I'd be able to find exactly where that point is that I should be at 42. So I might use the point 1042 because it's easier than using the decimals. And the other point I might use is if I'm looking at this and go, you know, instead right here it looks like at 3, it's at 12. So my hint to you is use points, not necessarily the data points, but points where it looks like it crosses that you don't have to write down decimals. The first thing you're going to do is find the slope with that. They did it with their 2 points, so I'm not going to do it again with these 2 points. You might want to try it. You might want to try using the 4210 or the 1042 and 312 and find, does your slope come out pretty close to what they had? Then we're going to go to our point slope form. We substitute in our slope. We substitute in one of our y points and one of our x points. Remember, the y goes first, then the x. Just the opposite of how our ordered pair looks. And they write an equation, and notice they have it as a decimal. So this is our new equation for our trend line. And then the question asks us, well, when in 7 months? Well, remember, 7 months was kind of in between here. So we could look up and go, oh, it looks to be about this, but we want an accurate answer. So what do? They go to their equation, replace x with 7, and solve to get 32.7 pounds.